All right, we've got a lot to unpack in this video. Today we're going to be taking a look at conductive cladding or plating over a conductive base material. So this isn't like measuring paint or non-conductive coating thickness over a base material. This is conductive plating or cladding over conductive base metal. Similar to like Inconel cladded on top of carbon steel, or perhaps aluminum on top of steel. I'm not sure why they would do that, but there's a way to measure it with eddy current. So we're going to take a look at that. Now, a common misconception is if you take a base material such as aluminum and you start plating it with copper, and that copper starts to follow a clockwise rotation, some people assume that if you plate aluminum on top of copper, that it's just going to follow that same path in the opposite direction. But that's not what happens. As plating gets thicker, it always rotates in a clockwise fashion. As the cladding is getting thinner, it will always rotate in a counterclockwise direction. Doesn't matter what the base material is or what the cladding is. Thicker goes clockwise, thinner goes counterclockwise. So that's kind of hard to imagine. So as always, I made some mock-ups here. And on the Workstation 2000, sorry for the angle there, I've calibrated this with 60 kilohertz. We're just going to use a couple different probes and frequencies. But now on purpose, I didn't vector ferrite straight up because I need a little bit of room to move around in my impedance plane. And I want everything to sort of fit in a way that will be most descriptive to your eyes. So I got ferrite there, 304 stainless, copper, nickel, magnesium, 7075 T6 aluminum, and then 7075 TAC 0 aluminum. And then I know I've got a copper sample somewhere. So copper is way at the bottom. And I may as well do my 99% copper, 99.9% silver Z-Tech coin. That follows right on top of that copper trajectory. Okay, so you can sort of see the conductivity curve. You've seen this 1,000 times, right? But what I'm going to do now is I'm going to erase that conductivity curve and those samples, and I'm going to touch my probe down to 7075 TAC 0 aluminum. Notice that trajectory. Now, this is just an aluminum plate, also 7075 TAC 0, so it follows the same trajectory if I don't get too wild with my probe. See that? Exact same. But on top of this plate, I've got some, I think this is 400 series stainless, but you know, very thin sheet. I'm not sure how many mils, but it's very thin. But let's take a look, see what happens when I start to touch the probe on cladded stainless steel on top of the aluminum. I'm gonna have to set it down. You're gonna have to trust me that I'm getting thicker with each movement of the probe. So that's the first thickness of stainless on top of aluminum. Now you may look at that and go, that doesn't look clockwise, it just looks vertical. Well, you have to keep adding thicknesses of the cladding. So when I go to the second sheet, or the second thickness, it goes vertical, but you can see that horizontally it moved to the right a little bit. So if you start off at the aluminum operating point, you know, once you've got 2 points, now you've got sort of a trend, right? It goes up, and then it goes up and to the right a little bit. Now I'm going to move on to the next thicker cladding sample. See how that's following clockwise rotation. The next thickness is here, and ultimately that's the thickest I have. And even when I add on more cladding, you know, that's the infinitely thick steel, whatever type of steel that is. But the plating definitely followed a clockwise rotation. Now I'm going to do the opposite. I have steel. Got some steel here with aluminum on it. So it's not going to, when I increase the layers of the aluminum, it's not going to just follow it back down to aluminum. It's going to follow a clockwise rotation down to aluminum. See, that's the tricky part. You don't believe it till you see it. That's why I spent all Saturday in here cutting all these little sheets of cladding out and pasting it to these blocks. So my loss of a Saturday morning is your gain, because you get to learn something about cladding and spiral locust. So first thing I'm going to do now, I'm going to keep this all on the screen so you can see this was aluminum, and then thin steel cladding, thicker, 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 infinitely thick steel. Now I'm going to touch my probe to the other steel sample I have, which is there. It's not exactly the same type of material. But now I'm going to start on the thin aluminum. Where do you think it's going to go? That way or that way? Well, we already know, because I told you it's going to go clockwise. Watch that. So that just looks like it went down, right? Well, let's just add a couple more in there. Now here, I'm going to have to take my gain down a little bit just to bring it back on screen. So that was my first thickness, second thickness, third thickness, fourth thickness, fifth thickness. And that's almost infinitely thick. Maybe this Reynolds wrap aluminum that I used for these cladding is a little bit different than the aluminum plate that I have here. But so real quick, I'm just gonna run through this all again, right? So there's our conductivity blocks. Here's my base aluminum. Then I'm gonna go on with the cladding of steel. Thinner, thicker, 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 clockwise rotation. And then now I'm going to go to a slightly different type of steel. And then I'm going to go to the first sheet of aluminum, second sheet. See how it's following clockwise rotation? All right, and just as a bonus, I happen to have, where is this copper here? This copper. Okay, so that's ferrite, that's copper. And then I have some grade of steel here. So that's that trajectory. Sorry. And then now I just have some thin copper. So I'm gonna put in the first copper. Which way do you think it's gonna go? That way or clockwise? We know it's going clockwise. Thicker, 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 and voila. See that? Now when I was playing around with this plate this morning, notice what happens when I touch the material on this side. And I'm staying away from the cladding. I'm just going in the base material. I turned it over, and I was going to put cladding the whole way down it, but I noticed when I touched different parts of the plate, I was getting these different trajectories. Well, what happened is somebody took this piece of material and they were testing out different types of paint on it. And obviously the two types of paint maybe have some lead in them. Maybe not lead, maybe something more conductive, because lead would be up towards the top, right? But there's definitely something different about these two types of paint versus the base metal. Sorry. And then now, we're on everyone's favorite tester, the Nortec 600. And instead of using a low frequency wider coil, we're just going to try the same evolution with, what's my frequency here? 300 kilohertz, so higher frequency, but a pencil probe, right? So again, I've got the ferrite vectored in that direction. Normal what did I do there? Normal conductivity samples. And my aluminum is going to be there. So I'm going to go back on the first sheet of steel cladding. Goes up and to the right, up and to the right, up and to the right, up and to the right. That's infinitely thick. So that went clockwise. And then I'm full, let's see, I gotta grab, that's aluminum. Oh yeah, so here's where I take the steel one. I'm just gonna erase the screen, touch the steel, and I'm gonna touch my first piece of aluminum cladding, and you know it's gonna go clockwise. Clockwise a lot. There's my third thickness. I'm gonna take that, uh-oh, that's a save. What I wanted was the gain. We're gonna take the gain down just a tad. Erase. So that was my base material, first sheet of aluminum, second, third, fourth, fifth, sixth, and there's my base material right there, infinitely thick aluminum. I'm running out of games here. We're just gonna do it with the copper real quick. That's gonna be the carbon steel base material, thin sheet of copper, another sheet, another sheet, another sheet, another sheet, bunch of sheets, and then our thickest, infinitely thick sample falls clockwise rotation. All right, I hope you enjoyed this video. End of lesson.